Good morning to all of you. Today we are going to discuss instruction set of 8085 microprocessor. As we all know that 8085 microprocessor is a 8-bit microprocessor which works based on set of instructions. The basic size of ALU is 8-bit. So all the registers are of 8-bit. There are basically 6 registers, 6 general purpose registers of 8-bit which are actually used for programming, that is called as accumulator, B, C, D, E and HL. These 6 are general purpose registers of 8-bit, whereas accumulator is a special 8-bit register which is used to store result as well as give the input to 8085 microprocessor. If we have to operate on 16-bit data, then we can combine these registers of 2 8-bit to make a 16-bit combination. For this purpose, the register pairs are fixed, that is B can be combined with C only, that is BC pair, D can be combined with E only and H can be combined with L only. So the register pair that we can use are BC, DE and HL. Now, during instructions, an instruction consists of 2 parts, that is opcode and operand, and the way in which microprocessor fetches this opcode and operand from memory will define various addressing modes, and the operation performed in these instructions will be given by the syntax of an instruction. The set of instructions which are defined for a microprocessor is called as its instruction sets. So for 8085, there are total 74 instructions defined which are grouped into 5 categories, that is data transfer, arithmetic, logical, branching and control instructions. These 74 instructions are further divided into 246 bit patterns. These 74 instructions are further classified into bit patterns, and 8085 consists of 246 bit patterns. So now we will discuss about various instruction sets. So as we all know that the instruction set of 8085 is classified into 5 types: data transfer, arithmetic, logical, branching and control instructions. As we can see that from this word data transfer means to copy data from source location to destination location. So in data transfer, it's just a copy paste operation, that is value of source is copied to destination. The source and destination can be register, can be memory address, location or can be immediate data. During arithmetic operation, 8085 can perform only 4 operations, that is addition, subtraction, increment, that is +1 and decrement, that is -1. The various logical operations performed by 8085 are AND, OR, XOR. These 3 are basic gates. Then rotate, compare and complement. So these are the list of instructions or the range of logical work performed by 8085 microprocessor. Now we talk about branching. Normally 8085, when an 8085 runs a program, it takes the next instruction from +1 address. That is, if a program starts from 2000 memory address, the next instruction will be fetched from 2001. But there are certain cases when we have to change the sequence of execution, that is called as branching. So to change the sequence of execution, we use either jump or call. When we have to change the sequence of execution within same program, jump is used, and when we have to jump from one program to another program, call instruction is used. And with call, to come back to main program, return instruction is used. Now, various control, that is machine control instructions are used to change the working or to instruct microprocessor regarding next set of work, like halt shows the end of program, no operation will only delay the program, RIM, SIM, EIDI are used for hardware interrupt, masking or unmasking, and so on. There are certain instructions which are used to instruct 8085 regarding certain work. So this is the full instruction set of 8085. Now we will go into detail of one instruction group, that is data transfer, in this lecture. So as I have discussed that in data transfer we just move the data between registers, memory or immediate data. These instructions simply copy the data from source to destination. So the source location can be register or memory address or immediate data, which is copied to destination. Destination can never be immediate data, so it can be register or memory location. So this is the whole set of values in data transfer instruction group. So the very first example of data transfer is move. Move simply copies the value from source to destination, and both the operands can be both the registers, that is RD and RS. So it copies the value of source register to destination register. For example, move A comma B, it copies the value of B to A. Or there can be destination can be memory location and source can be register. So this instruction will copy the value of register to memory location whose address is given in HL pair. M points to HL pair. So HL pair means two registers, that is 16-bit, which holds the address of memory location, and the value of source register is copied to this address. So the example can be move M comma A. This is just the opposite, that is this. In this instruction, the content of memory location is copied to destination register. So content of memory location which is there in HL pair is copied to destination register. When we talk about the size of these instructions as well as addressing mode, so as we can say that both the operands are in register, so the addressing mode of this instruction is register. Whereas in the next two instructions, the address of memory is given in register pair. So that is indirectly calling the memory. So addressing mode is indirect in both the instructions. When we talk about the size, both the instructions are of 1 byte. All the three instructions are of 1 byte only. Now when we talk about the machine cycle, in the first only two registers are there, so the only opcode fetch machine cycle will be there and only 4 T states. Whereas in second instruction, the register content is copied to memory location, that is written into memory location. So opcode fetch plus memory write. So total T states will be 4 plus 3, that is 7. Whereas in third instruction, the content of memory that is read to and copied to register, that is read out. So opcode fetch plus memory read plus total 7 is T states, 4 plus 3, that is 7 T states. So this is the way we classify or we explain all the instructions. So for any instruction, we need to understand 4 basic concepts, that is size of instruction, addressing mode of instruction, machine cycle of instruction and T state of instruction, in addition to its working. This is very important to know the size of a program as well as the time consumed by any particular program. So When we talk about move B comma A, if before execution accumulator is 20, then after execution this value is copied to B register, so B register will become 20. Similarly, if move M comma B and the HL pair contains 2050 as seen here, so the memory address of memory will be 2050. Let this memory location, let the content of B register is 30. So after execution, this value will be copied to memory with address 2050. So at this address 30 will be copied. Similarly, if we talk about next instruction move C comma M, that is content of memory location, let the address will be same 2050 and content is 40. So after execution, this 40 is copied to C register. So C register will contain 40. So in this way, move instruction will work. Next is MVI. I stands for immediate data. So in this instruction, immediate data is copied either to register or to memory location. Since the data is 8-bit and MVI RD take 1 bit, so the size of this instruction will be 2 byte. And if we talk about addressing mode, since we are calling data immediately, so it is of immediate mode, addressing mode instruction. Now we are talking about machine cycle. So as the immediate data has to be read, so a memory read and opcode fetch. So opcode fetch plus memory read, that is 4 plus 3, 7 T states. In second, data is read, so memory read, then this data has to be written to memory location. So one memory write also. So there are 3 machine cycles, that is opcode fetch plus memory read plus memory write, that is 4 plus 3 plus 3, 10 T states. So this is the overall classification of MVI instruction, addressing mode, size, machine cycle and T state. And this instruction simply copies the immediate data specified in instruction either to register or memory location. For example, MVI B comma 60, 60 is copied to B register, or MVI M comma 40, so 40 is copied to memory location whose address is specified in HL pair. For example, if MVI B 60, so before execution B is blank, after execution 60 is copied to B register. In this case, HL value is given as 2050, that is memory address is 2050, MVI M comma 40, so after execution, this at this address value 50 will be copied. So at 2050, 40 will be copied. Next is LDA, load accumulator directly with the content of memory address. So here 16-bit address is directly specified in the instruction. The data is read from this address and copied to accumulator. So this instruction simply copies the value of 16-bit address to accumulator. As the address is directly given in the instruction, so this instruction is of direct addressing mode. When we talk about size, 16-bit address requires 2 bytes and 1 LDA, so the size of instruction is 3 bytes. When we talk about machine cycle, 2 machine cycles are required, 2 memory read cycles are required to read the address, and 1 machine cycle is required to read data from this address. So there are 4 machine cycles. One is opcode fetch, then 2 memory read to read complete address, and 1 more memory read to read the data from that particular address. So to read lower byte of address, 1 memory read, then higher byte, 1 memory read, then this complete address is read. We will move to this particular address and then we have to read the data from this address, 1 memory read for that, reading that data. So there are 3 memory reads. So 4 plus 3, 3, 9, 4, 13 T states. This is the overall T state for LDA instruction. So the content of memory location with the specified address is copied to accumulator. For example, if the instruction is LDA 2000, the content of 2000 memory address is copied to accumulator. We will see the example. Let the address 2000 holds the data 30. So after execution, this 30 is copied to accumulator. If there is an X, that is LDAX, this instruction also loads the value of memory to accumulator, but the address is not directly specified. Address is given in register pair. And the register pair here used are either BE register pair or BC register pair. B means BC or D means DE register pair. So this instruction loads the accumulator indirectly with the content of memory address whose address is given in register pair. So as the memory is called indirectly, so this instruction is of indirect addressing mode. And since no address or data is specified in instruction, so no extra size is required. So size of instruction is 1 byte only. Now when we talk about the machine cycle, so BC, we are talking about LDAXD. So DE register contains address 2000. We don't need any extra cycle to read within microprocessor. So just opcode fetch. After that, we have to move to this address 2000 and read the data from this address. So one read cycle is required to read data from the address specified in DE pair. So we have to read the data, that is one memory read, and just copy it to accumulator. So no extra cycle is required. So total T state is 4 plus 3, which is 7 T state. I hope this is clear to all of you. So LDAX is indirect mode instruction where the content of memory location whose address is given in register pair is copied to accumulator. So the example is LDAXD. The content of memory address is given in DE pair. The memory address is given in DE pair and its content is copied to accumulator. So we will take an example. This is the instruction and D contains 20, E contains 30. So the address will be 2030. Let the content of this value is 80. So when LDAXD is run, the content of accumulator will be updated to 80. Clear? So I hope you get the difference between LDA and LDAX. In LDA, address is directly specified in instruction, whereas in LDAX, register pair is specified. The content of register pair will be address and the content of this address will be copied to accumulator. Now LXI. LXI is another immediate mode instruction, but in this the 16-bit immediate value is copied to register pair. One more we have read, that is MVI. In MVI, 8-bit data is copied to register, whereas in LXI, 16-bit data is copied to register pair. So as we all know, there are 3 register pair, HL, BC, DE. So we will just write first value. By default, second value will be H, L with H, C with B and E with D. So LXI, register pair, comma 16-bit data. So to read 16-bit data, we require 2 memory read cycle. First of all, this is again immediate mode instruction. Now we talk about size, 2 byte for data and 1 byte for opcode. So 3 byte instruction. And now we talk about machine cycle. So opcode fetch plus 2 byte to read the data. And we have simply copied it to register pair. So no need to read another thing, that is total 4, 3, 7, 3, 10 T state. So this is the size, T state, machine cycle and addressing mode. So this instruction simply loads 16-bit data to specified register pair. Like for example, LXI H equal to 2030. So 2030 will be copied to HL. For example, this is the register pair A, B, C, H, L. So like LXI H2030. So after execution, H will contain 20, L will contain 30. Now LHLD. LHLD load H and L registers directly with the specified address and address plus 1 location. This LHLD and SHLD are two special instructions which copy two consecutive memory locations to H and L respectively. Since the address is directly specified, so this is direct mode instruction, and it loads H and L registers with the data of address and address plus 1 location respectively. For example, the content of address, for example 2030, is copied to L, and address plus 1, that is 2031, is copied to H. So this instruction copies the content of memory location to given by 16-bit address to L, and next memory location, that is address plus 1, to H. For example, if we consider this instruction and let we use LHLD 2030, so let the address content is 00 and address plus 1 content is 85. So after execution, L will contain 00 and H will contain 85. So this is the only instruction which copies two consecutive bytes from memory to H and L respectively. All remaining instructions will copy only one location from memory, either directly or indirectly. Now, opposite of LDA is STA. During LDA, the value of address is copied to accumulator. It is just opposite, that is copies the value of accumulator directly to specified address. So directly means it is direct addressing mode instruction, and 16-bit address is specified, though again size of instruction is 3 byte. And when we talk about machine cycle of code fetch, plus 2 read is required to read the complete address, and then accumulator is copied to specified address, that is written into address. So one memory write. So total machine cycles will be 3, 3, 3 and 4, that is 13 T states. So this is the size, machine cycle, T state and addressing mode. So this instruction simply copies the content of accumulator to the specified memory address. For example, if we talk about STA 2000, let the accumulator before execution contains 50. When we run STA 2000, the content of memory location 2000 will become 50. As we have studied the difference between LDA and LDAX, LDA copies the value to accumulator directly, whereas LDAX copies to accumulator indirectly. Similar is the difference between STA and STAX. STA copies the accumulator directly to memory address, whereas STAX copies value of accumulator indirectly to memory address specified by register pair. So indirectly means this instruction is of indirect mode, and the content of accumulator are copied to memory location whose address is in register pair. So this is, there is no data or address specified, the size will be 1 byte. To read data, no extra cycle is required, so opcode fetch. And to copy the accumulator to specified address, it requires one memory write. So total 7 T states. Now, if we talk about register pair can be BC or D. Let we study STAX B. So let before execution, accumulator contains 1A and we run STAX B. So BC register contains 8500. So this is the address of memory 8500. The value of accumulator is copied to this address, that is after execution this address will contain 1A. As we have studied LHLD, which loads the value of address and address plus 1 to HL pair. SHLD is just opposite, that is copies the value of HL to address and address plus 1 location respectively. That is content of L is copied to address and content of H is copied to address plus 1 location. Since the address is specified, so it is of direct mode instruction, and 16-bit address is given, so its size is 3 byte. And when we talk about machine cycle, one is opcode fetch. To read the complete 16-bit address, it requires 2 read cycle. Then we have to write to address and address plus 1 location. So, 2 memory write. So, the total machine cycle will be 12 plus 4, 16 T states. I hope this is quite clear to all of you. Similar to LHLD. LHLD simply considers the difference. LHLD simply copies the value of address and address plus 1 to HL, and this is the opposite case, that is copies the value of HL to address and address plus 1 location. So, 2 memory write, whereas in case of LHLD there are 2 memory read. So, if we take an example SHLD 28500, let before execution H is 70 and L is 80. So, after execution 8500 will contain the value of L, that is 80, and 8501 will contain the value of H, that is 70. So, this concept is clear to all of you, how LDA, LDAX, LHLD, STA, STAX and SHLD are different. Now, we move towards exchange. Exchange is an instruction which exchange the content of HL and DE pair. That is, there is no operand. It simply exchange HL with DE. So, H is interchanged with D and L will be interchanged with E. Since there is no operand, so the size of instruction will be 1 byte. Addressing mode will be implied. Machine cycle will be only 1, that is opcode fetch. And since there is 2 register values are copied, so the instruction will take 60 states. So, the content of H will be exchanged with D and L will be exchanged with E respectively. So, let D contains 2040 and HL contains 7080 before execution. So, after execution HL will contain 2040 and D will contain 7080. So, I hope this is quite clear, very simple. Now, we talk about SPHL. SPHL simply copies the value of HL to stack pointer. SP is a stack pointer and HL is a register pair. So, it copies the value of HL to stack pointer. The addressing mode in this is implied. Size will be 1 byte. And when we take an example, let HL contains 2500. After SPHL, the value will be updated to stack from in a stack pointer 2500. Now, exchange XTHL. XTHL is quite different. It exchanged the top of stack memory with HL and contents. That is, it exchange H and L with top of stack memory whose address is given by stack pointer. So, the content of stack pointer will be exchanged with L and SP plus 1 will be exchanged with S. So, when we talk about size, it's 1 byte, but when we talk about machine cycle, it consists of 2 read and 2 write. So, opcode fetch plus 2 memory read to read the content of SP and SP plus 1 and to write the content in SP and SP plus 1 locations. So, the total T state will be 16. For example, before execution, let stack pointer is 2700, H and L will be 30 and 40. So this is the stack pointer content 50. L will be interchanged with 50. So L will contain 50 and 2700 will contain 40. Similarly, H is interchanged with SP plus 1. So this is 60 and H is 60. Both will be interchanged. 60 and H is 30. So H will contain 60 and L will SP plus 1 address will contain 30. So the H and L will be interchanged with 2700 and 2701 values respectively. PCHL will simply copy the value of HL to program counter, that is PC register, quite similar to SPHL. Push instruction is used to write onto stack. First of all, stack pointer is decremented because stack pointer points to the last filled location in stack memory. To write, we have to move to blank location, that is initially SP is decremented and then higher order register value will be copied to stack memory, and then SP is again decremented and then lower order register value is copied to stack memory. We will clear this by using an example. Let we use push B and the content of stack pointer is 2099. So 2099 is filled location. We have to first reduce it, that is 2098, and copy higher byte, that is 32 to this location. Then again minus 1 2097 and copies lower byte, that is 57 to this particular location. Pop is the reverse, that is read out the value of stack memory SP and SP plus 1 location to register pair. So copies the content of top of stack to register pair. So SP is first, the value of SP is copied to lower byte and SP plus 1 location is copied to higher byte. Let me take an example, pop H. So initially the register pair taken here is HL. Let SP is 2090. So the content of SP F5 is copied to L register. Then SP plus 1 2091 is copied to H register respectively. There are last two instructions in data transfer, that is in and out. These two instructions will move the data from IO port to microprocessor. Rest all the instructions copies the data from memory to microprocessor. So in copies the data from IO port with a specified address to accumulator. So in with 8-bit port address, the value of this address is copied to accumulator. Let the IO port is 80 with value 10. So in 80, when we run in 80, this value is copied to accumulator. So accumulator will contain 10. Next is out the value of accumulator to specified IO port with this given address. So let we take an example, out 50. So initially accumulator will contain 20. After execution, this port will contain the value of accumulator, that is 40. So this is the overall data transfer instruction group which we have covered in this lecture. In next lecture, we will cover the arithmetic and further instruction sets of 8085. I hope all the examples and instructions are quite clear to all of you. Thank you.